Hi all, welcome to the video. Today we are going to discuss about binary tree representation using linked list. Okay, consider this is a binary tree that we have 50, 30, 55, 40, 45 and 65. So very simple, I am going to represent this one using a linked list. So this is a linked list representation. So here we are using double linked list because every node in a binary tree may have two children, maximum two children, minimum 0 or 1. Okay, here 50 is having one left child and a right child, 30 and 50. So we are going to save the data in the form of a double linked list, and in the double linked list we have a left address field and a right address field. Left address field represents the address of the left child and right address field represents the address of the right child. In this case 50 we have two children. First left child is 30, right child is 55. So address of 30 will be represented in the left address field and address of 55 will be stored in the address field of 50, right address field of 50. Likewise 20 is having only one left child. So the address of 40 is represented in the left address field of 30, and 55 is having two children. One is one left child and a right child. Left child is 45 and right child is 65, and left child address field is 500 and is represented in the left address field of 55, and right child address field is 400. That 65's address field is 400 and that is represented at the right address field of 55. So this is a way that we are representing the binary tree in a linked list. Okay, and next we are going to discuss tree traversal methods. Okay, traversals in binary tree. The first traversal method we are going to discuss here is in-order traversal. In-order traversal is the rule for in-order traversal is first visit. So traversal in the sense we are going to visit each and every node in the tree. If it is a binary tree, if it's a binary tree traversal, we are going to visit each and every node in the binary tree. If it is a linked list, we are going to visit each and every node from head to the last node in the linked list. In this case, we are going to visit each and every node. So here, for visiting each and every node in the list, in the binary tree, we have a rule that first visit the left node, then visit the parent node, then visit the rightmost node. In this case, consider we are going to traverse through this binary tree using in-order traversal. So the procedure is very simple. I am going to discuss this concept to write a program for this. So you have to keenly observe what I am going to do with this. In this case, we will start the process from the root node. So all the operations, whether it is insertion or deletion or search or a traversal, whatever it may be, we are going to start with the root node. So root node is the key node that we have for traveling or inserting or deleting or any operations in the binary tree. So our initial address that we have will be 100. So we are having we will always have the address of root node with us, so for all the operations. So 100 will be available with us. So the next step is we are going to verify whether the node 50 is having any left child. So what's the rule? First go to the left node, then to the parent node, then the right node. So this is the rule. So first step we are going to do is we are going to verify whether the node is having any left child. So how will we verify? So we are going to verify whether the left address field of this particular node is null or not. In this case, the left address field of 50 or the address 100 is not null. That means one left node is there, left child is there. So immediately what we have to do, we have to move on to the left child. So the cursor or the traversal node Q travel to the left child. Okay. again verify whether here we are going to verify whether the node is having any left child. Then if it is a leftmost node, then we are going to print the parent node, the particular node, and then move on to the right node. So in this case 50 is having one left child, so we are moving on to the left node, and again we are going to verify whether the node is a leaf node or whether this node is an internal node. How will we verify? First step is to verify whether the left address field is null or not. In this case the left address field of 30 is 300, so it's not null. So what we understand that we have a left child in the for a 30, so move on to that node 300, so that means 40. We travel to 40, then we are going to verify whether the node is having any left child. Okay, the left address field is null, so no left child is there. Then the next step is print that particular node. Okay, print that particular node in the sense we will print 40. Next we are going to verify whether the node is having any right child. In this case right address field is null, so nothing to do with that. What is the next step? That means we completed the left address part of 30. Left address part of 30 is over. The next step is to print 30. Okay, then again verify whether the 30 is having any right child. In this case we don't have any right child, so 30 is completed. The processing of 30 is completed. What is the meaning of that? We have completed the left address field of 50. We have completed the left part of 50. The next step is we are going to print 50. Then we are going to move on to the right address field of 50. What is the right part? 600. Moving on to 600, verify whether 600 is having any left child. So each and every node we are going to process with the rule left node right. Once you reach to a particular node, first step is to verify whether the node is having any left child. If the node is having any left child, move on to that particular node, and then again verify whether the node is having any left child. So in this case we completed the left part of 50. Then we are going to verify whether the node is having any right child. Yes, the right address field is not null, that means we have a right child. Move on to 55. Verify whether the left address field of 55 is null. In this case the left address field of 55 is not null. What's the meaning of that? There is one. We are confirming that 55 is having one left child. Moving on to that left child, that is 45. Again we are going to process the left node right rule in this particular node 45. Verify whether the left address field of 45 is null. Yes, the left address field of 45 is null. Then what we are going to do, we are going to print that 45. So 45. Then again verify whether the right address field of 45 is null. Yes, the right address field of 45 is null. That means processing on the node 45 is completed. Then we move on to the previous node 55. In the case of 55 we completed left part of 55. Then what is the next? We are going to print that particular node 55, and then moving on to the right address field of 55, that is 400. Moving on to 400. 400 is what contains that node 65. Verifying whether the node 65 is having any left child. Yes, the node 65 is not having any left child. The address field is null. So what we are going to do is we are going to print 65. Then verify whether the right address field is null. Yes, the right address field is not null. The right address field is null. That means 65, the processing on 65 is completed. Moving on to the previous node, processing on 55 also completed. Then moving on to the previous node, processing on 50 also completed. That means our traversal is completed. Clear? So this is a procedure for traversal of Inorder. Okay. In this case, we completed the Inorder traversal. So the procedure is to complete this left node right procedure in a particular node. So that is a procedure. Again, we are going to discuss about the next traversal method, preorder. Preorder traversal. Preorder traversal. Node traversal and preorder traversal. Preorder traversal, the rule is node left right. Okay, we are going to start with root node. The address of root node is 100, that we have. We reached 50. We are going to, once we reach 50, we are going to process 50 with the rule node left and right. So in this case, first step is printing that node. The node left and right, in the sense we are going to print that particular node. That is the meaning of n. N in the sense we are going to print. L in the sense we are going to verify whether the left child is available. If the left child is available, we are moving on to that particular node and then process the same. So in this case, 50 is the node. So we are printing that value 50 here. Okay. Then the next step is verify whether the node 50 is having any left child. Yes, the node 50 is having one left child because it's not null. The left address field of 50 is not null. That means one left child is there. Moving on to that particular node. So we reached we reached 30. Again, we are going to process with the rule node left and right. So print 30 here. First step is to print, because the first step is printing that particular node. That is the meaning of n. Okay. Then verify whether the node is having any left child. Yes, the node is having any one left child, that is 40. Address is 300. Moving on to the particular node 40. Print that particular. We are processing node left right on this particular node 40. First step is to print that node 40 printed. Then verify whether the left address field is null. The left address field is null. Okay, nothing doing with that because it's null. We don't have any left child. Then processing the right address field. Right address field is also null. That means we completed the rule node left right on this particular node. Then moving on to the previous node, that is 30. We already completed n part and L part. We completed L part and n part and L part in this particular node 30. The next rule is next one is we are processing the right part. Right part is null, so that also completed. That means 30 also we processed. Moving on to the previous one. So in the previous one also we completed a node part. We printed 50. We completed the left processing part, that is left subtree we completed, we processed. Then the right part is pending. So moving on to the right side, 600. The right address field is not null. That means one address field is there. That means one node is there. Moving on to that particular node 55. Okay. In first step, we are going to process this 55 with the rule node left right. First step is to print this particular node 55. Okay, we printed 55. Then verify whether the node is having any left child. Yes, one left address field is there. Moving on to that particular node left. Here I am processing with the 45 with the rule node left and right. First step is to print 45. So we printed 45 here. Then verify whether the node is having any left child. Yes, the left address field is null. So left part also completed on this particular node 45. Right part also null. So node left right rule is completed on the node 45. That means we completed the left address field of 55. So the right address field of 55 is pending. We are moving on to the right address field of 55, that is for 65. The address field is 400. And first step is to process 65 with the rule node left and right. Okay, we printed 65 here, so n part completed. Then we verify whether the left address field is null. Yes, the left address field is null, so nothing do with that because we are not going to travel, because there is no provision for traveling to the left part. Then left part also completed. Then the right part is also null, so we completed the entire 65. The processing of entire 65 we completed. Then we completed the previous one, that is for 55. The node left to right rule also completed on 55. Again the node left right rule on 50 also completed. So the entire traversal process for pre-order traversal process is completed for this particular tree. Clear? Any doubt on this?